All right, so day 4 is about something called the unit circle. And the unit circle is going to take little bits and pieces of what we've been doing this unit so far and putting them together. So the unit circle has this equation here, x squared plus y squared equals 1, which you may remember from the beginning of the year means that the center of this circle would be at 0, 0, and the radius is 1. So we kind of have a picture of it over here, and our radius, is always 1 no matter what point we have on the circle. So again, this is on an xy plane, and the x coordinate of any point on the unit circle is going to be the cosine of whatever angle we are talking about. So if I wanted to know, the x coordinate of this point here, I would take the cosine of this angle, and that would give me the x coordinate. And then for the y coordinate, I would use the sine of that angle, and that would tell me the y coordinate. And as a little bit of a reminder, tangent, one of the definitions we've said for tangent is sine over cosine. When we're talking about one of the definitions of tangent. So you're going to have to learn the unit circle. And again, we're going to be practicing this for a little bit. So it's not something that you need to really sit down and memorize all in one day, but you should be working on memorizing it or figuring it out. And these are the things that you'll be expected to do. All the special angles from the previous day that we talked about up here. These special angles. You should know the degree and radian of those angles, degrees and radians. And for each of those points for those special angles, you should know the x coordinate, which again is the cosine of the angle, and the y coordinate, which is the sine of the angle. And then you should also be able to figure out how to evaluate the tangent of those angles, or sometimes it's easier to memorize those. Now, the next term that we need to discuss is called a quadrantal angle. And we've used those words, we've used this before, we just haven't called it the quadrantal angles. It's an angle in standard position whose terminal side is on an axis. And the quadrantal angle is always a multiple of pi over 2, or 90 degrees. And like I said, we've done that before up here. You see, at each of these quadrants, we had 0, we had 90 degrees, we had 180 degrees, 270, and 360. Those are all multiples of 90, and those are the angles that separate the quadrants, so they're called quadrantal angles. And the same thing is true in radians. Pi over 2, if I add 1 pi over 2 to 1 pi over 2, I get 2 pi over 2, which is pi. Add another pi over 2, that's 3 pi over 2. Add another pi over 2, that's 2 pi. So those are the corresponding angles in radians for those quadrant boundaries or quadrantal angles. So we've already been experiencing those before. Now on the unit circle, there are what I call families on there. And again, we've seen something like this before where, the other day we said, this has a denominator of 4, and this angle has a denominator of 4, and this angle has a denominator of 4. And so does this one, that has a denominator of 4. And they're just reflections of each other, and we would call that the pi over 4 family. And the pi over 6 has a family, and pi over 3 also has a family as well. So in the pi over 4 family, the reference angle is 45 degrees, or in radians pi over 4. The ordered pair, the cosine and sine value, or the xy, is some form of square root of 2 over 2, comma, square root of 2 over 2. And that may look familiar from, our first day of notes up here, where we said that the sine and cosine was square root of 2 over 2 for 45 degrees. So these values are going to be used down here in our unit circle. And the difference is, depending on your quadrant, something will be positive or something will be negative. So over here, okay, in quadrant 1, we have square root of 2 over 2 and positive square root of 2 over 2. If I reflect that over to quadrant number 2, well, in quadrant 2, my x values are negative, so this is going to be negative square root of 2 over 2, comma, square root of 2 over 2. And if I reflect that down here in quadrant 3, x and y are negative. So both coordinates are going to have, both coordinates are going to be negative. And if I reflect that in quadrant 4, well, in quadrant 4, the x values are positive and the y values are negative. So all of the pi over 4 family, or the 45 degree family, has a cosine and sine, or an x and y value of square root of 2 over 2, and then it changes based on the quadrant you're in. And then the tangent is going to be a form of 1. So again, when I say a form of something, that means it's going to be either positive that or negative that. So all of the 45 degree or pi over 4 family is going to have a tangent of either 1 or negative 1. Now the 30 degree family, or the pi over 6 family, they have a reference angle of 30 degrees, or pi over 6, and the ordered pair is square root of 3 over 2, comma, 1/2. Because from our day 1 notes, when we were doing 30 degrees, the cosine of that was square root of 3 over 2, and the sine of that was 1/2. And the tangent is a form of square root of 3 over 3. So again, over here, 30 degrees in quadrant 1, both are positive. If I reflect it over here, x is negative, and reflect that down here, x and y are negative. Oops. And then over here, x is positive and y is negative. And, again, that the x and y coordinates, we can also refer to them as the sine and cosine values. The cosine of 150 degrees is the x coordinate here, negative square root of 3 over 2. Now, the pi over 3, or the 60 degree family, is similar to the 30 degrees and pi over 6 family, except these are now switched. The x coordinate, or the cosine, is a form of 1/2, and the sine is a form of square root of 3 over 2, and the tangent is a form of square root of 3. So again, quadrant 1, everything's positive. Quadrant 2, x is negative and y is positive. Quadrant 3, both x and y, or sine and cosine, are negative. And in quadrant 4, cosine, or the x, is positive and sine is negative. So the unit circle, we're going to have all three of these families on it overlapped, and then also the quadrantal angles. So on the next page here, this is the blank copy of the unit circle that you'll be expected to produce on a test or quiz. And you'll get this exact picture, and you have to fill in the missing information. So what I like to do first is I like to go around and do the radian angles. So it starts with 0, and then the first one is pi over 6. We talked the other day how the denominators in the first quadrant go 6, 4, 3, and the numerator is always 1 pi over that, and this is pi over 2. Then we talked about how we can reflect this point over here, and it's still going to be a denominator of 3, and that the numerator is going to be 1 less than the denominator, so 2 pi over 3. We also talked about how the denominators go in the reverse order as they did in the first quadrant. Okay, the numerator is going to be 1 less than the denominators, so we have 3 pi over 4, 5 pi over 6. Then half a circle is pi. And then down here, the denominators again go in reverse order, 6, 4, 3. But the numerator is now 1 more than the denominator. And then this is 3 pi over 2. And then denominator 3, 4, 6 again. And this was the little bit different, confusing one. 2 times the denominator minus 1. So 3 times 2 is 6, minus 1 is 5. 4 times 2 is 8, minus 1 is 7, so it's 7 pi over 4. 6 times 2 is 12, minus 1 is 11 pi over 2. And then we have 2 pi. Now, the angles, I think, are maybe a little bit more confusing, but sometimes people do well with those because it's easier to see which one's bigger and smaller. Some people may struggle, hey, is 2 pi over 3 bigger or smaller than 3 pi over 4? So our angles in degrees start at 0 degrees, then it's 30, 45, 60, and then 90 degrees. Now, over here, if we reflect our 60-degree angle, it lands right here. So that's going to be 120 degrees. And then over here is going to be 135 degrees. And then the next one is going to be 150 degrees. Some people will say, like, you add 30, 15, add 15, and add another 30. Okay, then we get 90, add 30, we get 20, add 15 is 135, add another 15 is 150, add 30 gives us 180. So you could think of it that way. You could add 30, add 30, 15, 15, 30. All right, so 180, add 30, 210, add 15, 225, add 15 again is 240, and then add 30 is 270. All right, add 30 is 300, add 15 is 315, add another 15 is 330, add another 30 is 360. So that's one strategy. Another strategy is to do all the families at once. Like you could do the quadrantal angles and then do all the pi over 6 or 30-degree family. There's really no best way to do it. It's whatever makes sense for you. Okay, now the ordered pair. Now, with the ordered pair, in quadrant number 1, the cosine is positive and the sine is positive, or the x and y. X, y. In quadrant 2, x or cosine is negative and sine is positive. The x and y. In quadrant 3, both are negative. Cosine and sine are both negative. And in quadrant 4, cosine is positive and sine is negative. And again, and maybe I have it right here, but again, we can just write it. The cosine is your x value, and sine is your y value. And we can use those interchangeably and say, okay, what is the x value here? Or what is the cosine value? So for the pi over 6 family, the x coordinate, actually, no, we should start at 0, because that would be a little bit easier. If here's our origin, 0 degrees is 1 over and 0 up. So that's 1 comma 0. Now, pi over 2 or 90 degrees, I'm going from my origin just straight up. So 0 comma 1. And then from the origin going to pi, that is negative 1 comma 0 because I'm going to the left. And then 270, 0 comma negative 1 because I'm going over 0 and down 1. Okay, so I'm going to do the pi over 6 family. And over here, I'm going to write down the different numbers that we have here for the sine and cosine value. It's either square root of 2 over 2, square root of 3 over 2, or 1/2. So square root of 2 over 2, square root of 3 over 2, and 1/2. Now look at the x values. This x value, if we translate it down, should be bigger than this x value if we translate it down, which should be bigger than this x value if we translate it down. So this has to have the biggest x value of these three numbers. Well, the square root of 3 is bigger than the square root of 2, which is bigger than 1. So this got to be square root of 3 over 2. The next biggest one is the square root of 2 over 2. And then 1/2 is the smallest of all of them. Now the y values, the square root of 3 over 2 and 1/2 go together. So the y values for those have to be, for pi over 6 has to be 1/2, and for pi over 3 is square root of 3 over 2. And at 45 degrees, they're both the same. Remember what we had on our first day of notes, that the sine and cosine of 45 degrees was the same. Okay, so with the first quadrant done, I'm now going to translate these points over here. So I'm going to take this point and translate it over to this other pi over 2. So my x coordinate is going to be negative 1/2, and the y is going to be positive square root of 3 over 2, because in this quadrant, in quadrant number 2, cosine is negative, the x value is negative, and sine is positive. Then taking this point and translating it over here for the pi over 4, so it's negative square root of 2 over 2, comma, positive square root of 2 over 2. And then lastly, translate or reflect this point, the pi over 6, to 5 pi over 6. The x is going to be negative square root of 3 over 2, and the y is going to be 1/2. Now we're going to reflect these points down. So 7 pi over 6, I'm going to take 5 pi over 6, reflect it down. The sine and cosine values are negative in quadrant 3 because those are negative x and y values. 5 pi over 4, if I take this 3 pi over 4 and reflect it down, that will make both values negative square root of 2 over 2. And then I can take 2 pi over 3 and reflect that down to negative 1/2, comma, negative square root of 3 over 2. Now, or you could have just taken your pi over 6 and changed them, like switch spots, and then you would get your pi over 3 family. And then lastly, over here, 4 pi over 3 will reflect over to 5 pi over 3, but the x will be positive 1/2, the y is still negative. Pi over 4 is going to be positive square root of 2 over 2, comma, negative square root of 2 over 2, because I'm reflecting this point. And then reflecting 7 pi over 6 into 11 pi over 6, positive square root of 3 over 2, comma, negative 1/2. So that is just one way to construct the unit circle. There are other ways that we'll talk about as the year goes on, or this unit goes on. That's just one way. Some people do it totally based off of reference angles, like saying, they memorize that the pi over 6 family has this type of form, and then they figure out which one should be positive or negative based on the quadrant. That's the way I personally do it, but I know until you get better at this, that is a little bit more difficult. So now we're going to evaluate without using the calculator. So what that means, the sine of 135 degrees is I want the y coordinate of 135 degrees. So that would be square root of 2 over 2. So that is the value. The cosine of 210, I want the x coordinate of 200 degrees, so that's negative square root of 3 over 2. The sine of pi, so at pi, the y coordinate is 0, so this is 0. And then the sine of 11 pi over 6, 11 pi over 6 is right here. The y value is negative 1/2. So the sine of 11 pi over 6 is negative 1/2. Cosine of pi over 4, the x value there is the square root of 2 over 2. The cosine of 0, so the x value at 0 is 1. Now, tangent. You could always just figure out the tangents and say, well, tangent of 60 is the same thing as the sine of 60 degrees over the cosine of 60 degrees, and then go back up here and say, okay, sine is the square root of 3 over 2, and the cosine of 60 is 1/2. And then simplify that and say, okay, square root of 3. That works. You can always do that. I like just memorizing the tangent values for these ones because, one of the tangent is just 1, a form of 1, and then we have the square root of 3 over 3, and then the square root of 3. The way that I usually tell students to remember it, for the pi over 3 family, the tangent is the square root of 3. And for the pi over 6, well, square root of 3 over 3, 3 plus 3 gives you 6. So for the pi over 6 family, it's got to be square root of 3 over 3, because 3 plus 3 is 6. The pi over 3 family is just the square root of 3. That does not work for the degrees, though. So just keep that in mind. So tangent of 5 pi over 4. This one, I'll do this one as sine over cosine one last time. Now the sine of 5 pi over 4, the y coordinate is a negative square root of 2 over 2, and so is the x coordinate. So it's going to be negative square root of 2 over 2 over negative square root of 2 over 2, which is negative square root of 2 over 2 times the reciprocal to negative 2 over square root of 2. Everything will cancel out, and we just get 1. Okay. Negative times a negative is positive. So that's why it cancels out to positive 1. Even though the sine and cosine values were negative, the tangent was positive because negative divided by negative is positive. So that might be something we should add up here. In quadrant 1, the tangent is positive. In quadrant 2, tangent is negative. In quadrant 3, tangent is positive, and in quadrant 4, tangent is negative as well, because the only way for your tangent to be positive is if you have a positive over a positive or a negative over a negative. Then the last one, the tangent of 2 pi. Well, again, tangent of 2 pi, this is the same as sine of 2 pi over cosine of 2 pi. Sine of 2 pi, the y value is 0, so it is 0 over 1 or 0. All right. Tangent of 270. Tangent of 270, that's right here. Cosine is 0 and sine is negative 1. So this is, again, the sine of 270 over the cosine of 270. So that is negative 1 over 0, which we can't have, so this is undefined. So I want you to just understand the difference between filling in the unit circle here and then evaluating. So I'm looking for the x and y coordinates or the tangent when I'm asking you to evaluate these functions. So that's it for our introduction to the unit circle. I would suggest studying this and starting to figure out maybe some other patterns that make sense to you. Make flashcards or find an online flashcard to get started on learning this. So thanks for watching. Make sure to like our video and subscribe.